two linear functions are shown. So I don't have to worry about checking to see if it's linear. I know they're both linear. Obviously, function b is linear because it's a straight line. But I'm just going to go ahead and assume that the table is linear because it says so. So it's going to ask, which function has a greater rate of change? Which function has... So what does it mean, rate of change? That is just fancy for what? Slope. That is just fancy for slope. So let's do function b. That's going to be the easier one. I'm just going to write f of x for function. I don't really want to... So f, function b. How do we find slope for function b? That's very simple.
Find a slope.
Huh? Yeah, you can, Sam. Thank you for asking. Mushabash, you're correct. Find 2 points and then do rise over run. So I need 2 points for function b. I'm going to start off with the y-intercept because that's always easy. So what is across the y-intercept at 0, comma? Function b. Huh? What's the y-intercept of function b, Sophia? Are there no better points than that? Oh, no, let's use a different point. Yeah, no, let's not use that point. Let's use where equals 1. So when x equals 1, what is y equal? Bro, what? That is a whack function. All right, we're going to have to use decimals. No, we got to use decimals. That's how it is. 2.5 and then 1 and 3.5. So we have our functions here. And we got to plug it into our slope formula. So we're going to go x1, y1, and we'll do x2, y2. And we'll just go ahead and subtract like normal. So we'll have 3.5 minus 2.5. And we'll have 1 minus 0, which means my slope equals a nice perfect 1. Slope equals 1 for function b. All right, now, so Emmy, for function A, how do I find my slope? And how would I use this? Which points do you want to use? Awesome. So which one do you want to make your ones? You're going to use 4, 32, and 8, 44. Which ones are our ones? Which ones are our twos? The 401. So x1, y1, x2, y2. So, Emmy, plug it into our formula. We're going to have...
44 minus 32, and then 8 minus 4.
There you go. And that's going to give us 12 over 4, which reduces down to 3. Now, these are not our answers. What is the question asking for, Josh? Oh, you're not Josh. Which is just fancy for what? The slope. And which one has a greater slope? Function A or function B? Which one's a bigger number? Wait, what? Which one's a bigger number? Wait, what? Which one's a bigger number? 3. So that is function A or function B? Function A. There you go. Function A is your right answer. It has the largest slope. Function B has a slope of 1. Function A has a slope of 3. And it just asked for which one was greater. Okay. Example 2. You're good. Don't worry about it. Oh, wait. Don't worry. You're chilling. Okay. Example 2, we're no longer looking for slope. What are we looking for? Well, the y-intercept. We're basically looking for the y-intercept. So this is function A, this is function B. Whoops. We're just looking for the y-intercept. So what is the y-intercept of A?
5.
Yep, it's 5, because in the equation it says plus 5. And then what is the y-intercept of B? How do you know it's 8?
Because x is 0.
Because where x equals 0, y, whatever the y value is 8, right? So we have our y-intercept. So which one has a greater initial value? Let's go with Jason D. Which one's the correct answer? Function B or function A? Are you saying that just because she said that?
No, because A starts from 5.
I understand. What does B start with? Where does B start?
Negative.
What?
Oh, never mind. You have it's B. It's 8.
What? Because it's 8, right? So function B is the correct answer. The y-intercept is greater for function B. Basically, yeah, if it asks for the greater one, it's the right answer. Sometimes it'll ask for less than. All right. That's example 2. Example 3 is a little tougher. Example 3 says tell whether the function is linear or nonlinear. So you're going to have function A, and then you're going to have function B. This one looks like this.
That's like a
So this looks like this. And then function B is actually pretty easy. Let's go with Sophia. Which one's the easier one to figure out, A or B? If it's linear or nonlinear? Why? How is that easier?
Oh, my bad, B.
Why is it easier?
Because you can tell it's straight line.
You can tell it's just not a straight line, right? So for function B, is it linear or nonlinear?
Non-linear.
Function B is nonlinear. All right, so for function A, it's a little tougher. We're not given a graph that we can look at, right? For function B, we can just look at the graph and say, oh, it's not a straight line, it's curved. But function A, we have to do something very specific. What do we have to do?
And you have to two.
You got to find the slope of 2 different points. So we have to do our slope formula twice for 2 different points. So I'm going to do a slope line there and a slope line there. And I'm going to go ahead and write the slope formula right here. So let's go with Barone. Choose 2 points that we can use.
Let's go 1, 0,
1, 0,
2, negative 1.
and 2, and negative 1. All right, which one do you want to make your ones? Which one do you want to make your 2s? All right, here. So you're going to have your 1, 0, and you're going to have your 2, negative 1.
Which one would you get the easiest?
I would say the top one is your 1s.
Okay, let's do that then.
Okay, let me label that. So you're going to have your x1, you're going to have your y1, you're going to have your x2, and your y2. Okay, so now you're going to have negative 1 minus 0, and then you're going to have 2 minus 1, and that equals? Oh, negative 1. Yep, so my answer reduces down to what?
Negative.
Negative 1, right? So that's my slope. All right, now let's go with Sam. We have to use 2 separate points. Barone already used these ones and these ones. We can repeat one of them, but we can't repeat both of them. So what 2 points do you want to use?
4 and -3 and -2.
There you go. So I'll write those over here. We're going to have negative 2, comma 3. And your other point was 4, comma negative 3. All right, which one do you want to make your 1s? Which one do you want to make your 2s? The bottom one, 2s, x, y, 2. This is x, y, 1. All right, so that's going to look like negative 3 minus 3. And then you're going to get 4 minus negative 2. So, Sam, what does that reduce down to? Negative 6 over. when you have a double negative, it turns into a positive. So this actually ends up being plus 2. 6, and then negative 6 over 6 reduces down to. Well, what's 6 divided by 6? And then make it negative. Negative 1. So, Emmy, to answer, is function A linear? Huh? I can't hear you.
Yes.
Why?
I don't
All right, someone else. Sophia, why are they linear? Why is it linear?
We got the same 2 points each time we did.
You have the same slope for 2 different points, right? So function A is linear. And what I circle in green is your answer. Okay. So let's go to example 4, which is a little easier. Example 4 says, tell whether the graphs are linear or nonlinear. So you have function I, or 1. Then you have function 2. Then you have function 3. Okay? Let's start with function 1. Let's go with Sophia. Function 1, is it linear or nonlinear?
Non-linear.
Non-linear.
Be linear, does it have to go to the origin or does it
It can be anywhere. It can be anywhere, yeah. Let's go with Emmy. Function 2, is it linear or nonlinear? It is linear. And then trick question, Josh, function 3, is it linear or nonlinear? And low key, let me check it. Is the graph of the absolute value of x linear? I don't think it is, but let's check.
Okay.
Haha! Maybe I'm wrong. Okay,
Okay, so it's linear, got it.
where is it? There it is. Okay, so, Josh, function 3, is that linear or nonlinear? Why? They're both straight lines. That's not necessarily true. You're right. It touches the x-axis at like, it doesn't go through it, but it does touch it. That origin doesn't necessarily matter if you're looking at linear or nonlinear. It doesn't have to go through the origin for it to be linear or nonlinear. But Josh, you said nonlinear. I'm going to tell you that you're correct, but I want someone to tell me why Josh is correct. This is nonlinear. But why?
Still turns.
There's straight lines, but Jason Misherbosh,
It still like turns.
it makes one angle cut. There is an angle, Emmy. No talking. If you compare this graph, let me clear the board and draw what the graph is, right? So we have this graph. And it looks like this, right? Something like that. This slope right here is a negative slope. This slope is a positive slope, which means it's different because you have different. It means it's not linear because you have different slopes. Example 5. Example 5. Yeah, I couldn't change the name of this one. So Jeff saves $500 from his summer job, so he would have spending money during the school year. He withdraws $12 from his account each week. So a linear function models his plan. So what does that mean? If a linear function models his plan, which means we can use what formula?
Y2 equals
Nope. Y equals
Oh, mx plus b.
mx plus b. If you see something, a word problem that says it's linear, that means you can use y equals mx plus b. Then it says, Melissa made a similar plan. The table shows the results of her first 5 transactions. Compare the functions. So, example 5, letter A, says write an equation that represents Jeff's finances. So we're talking about Jeff. And we want to use y equals mx plus b. So, according to our word problem, what is his initial value? What is his y-intercept? What is b, Jason?
500.
Yeah, so we're going to add 500 because it says he saved an initial 500. All right, now what is the last thing that we have to figure out? Slope. Let's go with Sam. What is the slope of Jeff's transactions? At what rate is he spending or saving?
10, 12,
12 what? And is he spending or is he saving? He's spending, so is it going to be positive 12 or negative 12? Negative 12, yep. So y equals negative 12x plus 500. This is your equation that represents Jeff's spending.
What about Melissa?
It doesn't say Melissa. Awesome. So, this is A. Let me clear the board. So, A, we have y equals negative 12x plus 500. Letter B, we want to know who has a greater rate of change. Well, each week, according to our chart, how much is Melissa spending? $10. So who has a greater rate of change? Now, technically, if you want to get technical with it, I'm sorry, this is a dumb question, or I don't like the way it's worded. Jeff is spending $12, and you represent that with negative 12.
Oh, and you're gonna be like, great.
Melissa is spending at a rate of negative 10. Which one is a greater value on a number line?
Melissa.
Technically, Melissa is the right answer. Let me rephrase the question. Who spends more a week? Jeff. And if you were to get technical, what number is greater? Negative 10 or negative 12? Negative 10 is greater. So let's just stick with what the question asked. It is technically Melissa because she spends less. All right. I will not. Yeah, it's because it's the less value. Or it says which one's a greater value.
It's Melissa.
Yeah, watch on a number line. Which one's greater?
10.
Yep, negative 10. Right. It's technically greater.
But like it says rate of change and negative 12 is different, like more different than
Slope is positive and negative, so I know. So Jeff is spending more, right? Jeff is spending more, but Melissa technically has the number that is greater. Now let me rephrase the question. Who spends more? Jeff. So if I give you a test question, I'm just going to put who spends more. Is that cool? I won't be doing this stuff to you.
so we come up.
It is technically Melissa. Yes, for this question, it's technically Melissa. All right. Letter C. Which function has a greater initial value? Well, I know that Jeff starts with $500. It says he saves $500. Well, how much does Melissa start with? Nope.
No, 520.
Nope.
Oh, wait, 520.
Oh, it's five. Why is it 520?
Hey, I said 520. You said.
Oh, sorry. I thought you said 500. Sorry.
$10 different.
Yeah, because she spent $10 the first week, which means she started with 520. Now, here's the way you can solve that. I'm going to take the point 1, 510. This is my x, this is my y. And I'm going to plug it into y equals mx plus b. Well, I know that y is going to be 510. The slope is 10 times 1 plus b. If I solve this, whoa, the slope is negative 10. I'm sorry. The slope would be equals negative 10. If I go ahead and solve this equation, I would get b equals 520. But you guys can look at the chart and determine it on your own. So the answer is, who has a greater initial value? Melissa. Ironically, the book told me that it was Jeff. Because the book is wrong.
Well, never trust resources sometimes.